Now that we know how to factor quadratics, we can go on to solving them. When you're solving a quadratic, it means to find the x-intercepts, which is where the graph crosses the x-axis. If you look at the graph on the left, where is this crossing the x-axis? So here, and that's a really bad version, but that is your coordinate plane. So it's crossing at -1 and at 3. So when x equals -1 and x equals 3, you have x-intercepts. So it's crossing at the point -1, 0 and at 3, 0. And when you're finding zeros of a function, what you're doing is you're setting the function equal to 0. Remember that f of x is the same thing as y. Okay, so y equals 0, f of x equals 0, same thing. When it crosses the x-axis, it's called a couple of things. Okay, we call it the x-intercepts. And it's the same thing if we're talking about the solution, and if we're talking about the zeros. Okay, so zeros, x-intercepts, and solutions all mean the same thing. You're finding where the graph of the parabola is crossing the x-axis. To find it, what you're doing is you're taking the function and you're setting it equal to 0. And you're making sure that it's in standard form. So we'll talk about that in a minute. Okay, first we're going to look at some graphs. So on the first graph, where are the x-intercepts on the graph? Okay, so it's crossing at 2 and at 6. X equals 2, x equals 6. So that would be the point 2, 0 and the point 6, 0. If you look at the second graph, okay, where are the x-intercepts on this graph? Okay, it's touching at 1. So it's not crossing. The parabola does not go through the x-axis. What's happening is it comes down, it touches at 1, and it bounces back up. And we'll talk about that again later in coming chapters. But right now, that's all we need to know. The last one, where are the x-intercepts on this graph? Okay, so it's free floating. So since it's free floating, it means that it's not touching the x-axis at all. So there are no x-intercepts in this case. Okay, we have 3 options when we're solving quadratics based on how many solutions you get. If you have 2 intercepts, that's the most you can have with a quadratic. That means that the parabola is going to cross twice. It's crossing the x-axis 2 times. If you have 1 intercept, it's going to touch it once. Touch once. And I'm going to say touch instead of cross because it's not going through that point. It's getting to it and it's bouncing back. The third option is if you have 0 intercepts, like that last example where it was free floating. If there's 0 intercepts, okay, that means it doesn't cross. Okay, how can we solve for these x-intercepts? Well, we'll do that in the next slide. What is the y-coordinate for each of the x-intercepts? Now remember, if you have an x-intercept, okay, an x-intercept is crossing your x-axis. Here's your x-axis. So the y is always going to be 0. All right, so if we want to solve for x when y is 0, we have to find the x-intercepts. So you're taking y and you're replacing it with 0, since we know y is always 0. How do we solve for x? Well, think abstractly for a moment. If you have a times b, and that equals 0, what does that tell you about a and b? What do we know about a and b if when we multiply them, it gives us 0? Well, it means that one of them has to equal 0. Okay, so if I have x minus 5 and x plus 4, one of those has to be 0 in order for my y to be 0. So if x minus 5 was 0, that means x would have to be 5. Okay, 5 minus 5 is 0, 5 plus 4 is 9, 0 times 9 is 0. Same idea with x plus 4. If I set it to 0, x equals negative 4. So if I plug that in, I would get negative 4 minus 5, which is negative 9, times 0, so I'm going to get 0. So let's look at an actual example. So here we have a quadratic. First step is that we want to set it equal to 0. So x squared plus 7x plus 6 equals 0. Then we're just going to factor like we did last week. So multiplies to 6 and adds to 7. So I can use 6 and 1. And then since my a value is 1, I can use my shortcut. So I have x plus 6 and x plus 1. So what I'm going to do now is I'm going to set those equal to 0. So x plus 6 times x plus 1 equals 0. Each factor gets set to 0. X plus 6 equals 0. I solve it, I get negative 6. X plus 1 equals 0. I solve it, I get negative 1. So negative 6, 0 would be one of my x-intercepts. Negative 1, 0 would be my other x-intercept. And let's look at another one. So same idea. X squared minus x minus 2 is set equal to 0. And then I can factor, so it multiplies to negative 2, adds to negative 1. So I'm going to use negative 2 and positive 1. Again, a is 1, so I'm going to use my shortcut, x minus 2, x plus 1. So I'm going to take those, and I'm going to set them equal to 0. So x minus 2 is going to equal 2. X plus 1, when I set it to 0, is going to equal negative 1. So I have 2, 0, and I have negative 1, 0. Those are my two x-intercepts. So if I were to graph this, my parabola is going to cross the x-axis at 2 and at negative 1. In this example, it's slightly different now because we don't have a y. It's not y equals our function. Now we have terms on each side of the equal sign. So what we're going to do is just set it to 0. So I'm going to move over my 5x. And you want to make sure that you put this in standard form. So the 5x is going to go in the middle. Do not tack the 5x to the end. It has to be in standard form. Once it's in standard form, a is not 1, so I have to do AC. So it multiplies to negative 6 and adds to negative 5. So the two numbers I can use, negative 6 and positive 1. Okay, we can't use our shortcut since a is not 1. So the 2x squared comes down, the negative 3 comes down. And we're going to rewrite negative 5x using the two factors that we found. So minus 6x plus 1x. Now that we have four terms written out, we're going to group them. Group the first two, group the second two. And take out the GCF, so 2x squared minus 6x has 1 in common. They have a 2x, so you're left with x minus 3. X minus 3 has a positive 1 in common, x minus 3. So now we're left with 2x plus 1 and x minus 3. So bring those down and set each of those equal to 0. So 2x plus 1 equals 0. Subtract 1. 2x equals negative 1, and then we divide it by 2. So x equals negative 1/2. X minus 3 equals 0. X equals 3. So my x-intercepts are negative 1/2, 0, and 3, 0. Alright, so let's look at these examples. Same idea. Okay, we're going to set it equal to 0 first. 2x squared minus 11x equals 0. Take out the GCF. So they have an x in common. 2x minus 11 equals 0. So we're going to set each factor equal to 0. Now x is already solved for. If x equals 0, it's solved that x is 0. So now we just have to solve 2x minus 11. So I'm going to get 2x equals positive 11, x equals 11 halves. So my intercepts are going to be 0, 0, and 11 halves, 0. Okay, next example. Set it to 0. Here we're looking for what multiplies to 45 and adds to negative 14. So we can use negative 9 and negative 5. Set it to 0. Solve each one. So x equals 9 and x equals 5. So we know that our x-intercepts are going to be 9, 0, and 5, 0. And now think back to when we did graphing. What is my y-intercept here? So if we look at the original problem, how do we find the y-intercept? And so it's 0, comma c. Our c term is 45. So 0, 45. What about the vertex? How do you find the vertex? So first we have to do negative b over 2a. So 14 over 2 is 7. And then how do you find the y once you have the x? And we plug it back in. So 7 squared minus 14 times 7 plus 45. So we'll get y equals negative 4. So my vertex is 7, negative 4. Before when we graphed, we were able to have the vertex, have the y-intercept, and then use symmetry to find the third point. But now we can find the x-intercepts, and now our graph will be more accurate. So let's look at this. So if I go to graph, my vertex is 7, negative 4. So about here. My x-intercepts are at 5, 0, and at 9, 0. And then my y-intercept is going to be way off the graph somewhere up top at 45. So I'm just going to connect these. Okay, and here we have a more accurate graph because we have our x-intercepts, our y-intercept, kind of, it's off the graph, and our vertex. Okay, so for right now, you don't need to worry about graphing it. We're going to do that next class, but you guys are just going to find the x-intercepts right now. Okay, the last example we're going to go over, 2x squared minus 8 equals 0. First, take out the GCF. So you're going to take out a 2, and you're left with x squared minus 4 equals 0. And we're going to factor x squared minus 4 to be difference of squares. So x plus 2, x minus 2 equals 0. Okay, when we go to solve this now, these are simple, right? X plus 2 is 0, so x equals negative 2. X minus 2 equals 0, x equals 2. I can't set this to 0. 2 equals 0 doesn't make any sense. Okay, I can't solve it. There's no x. I just have 2 is 0, which is false. So I don't count that. Okay, my two answers are going to be negative 2, 0, and 2, 0. Okay, anytime you have a constant on the outside that you factored out when there's no x, it's not going to be part of your answer. So you can even divide it out. In the beginning, you could divide everything by 2. So you're left with just x squared minus 4 equals 0. And that way you don't have to even worry about that 2 anymore. And it only works when you have a constant on the outside. If there's a 2x on the outside, you can set that to 0. 2x equals 0. It's being able to be solved. 2 cannot be solved to equal 0.